In this class, I will explain one or two problems on application of D'Alembert's principle. In the earlier video, I had explained about the concept of D'Alembert principle and its applications. So the problem is like this. There is a block of weight 1000 Newton is kept like this on a horizontal plane, which is a rough plane, and a force of 750 Newton is applied at an angle of 30 degrees. It's a push force on this block. So the question is, determine the acceleration with which the block starts moving. So because of that external force P, that 750 Newton, the block tries to move in this direction, and of course, since it's a rough surface, we have given the coefficient of friction between the block and the horizontal plane as 0.25, that is mu value. The question is, what is the acceleration with which the block starts moving in the direction of the force, of course. Now the solution was like this. So you know that this is a problem of dynamic equilibrium, wherein we can use the concept of D'Alembert's principle. Let me write the free body diagram of the block. So when you are using the dynamic equilibrium concept, you have to introduce the inertia force also, which acts in the opposite direction of the direction of motion. So here the block is like this. So the weight of the block is 1000 Newton. So force P, of course, I am going to resolve it. The horizontal component and has the vertical component like this. So this force is resolved now, like this and like this. So this force is 750 cos 30 horizontal component, whereas this force is 750 sin 30. And since the force is acting in this direction of motion will be like this. So if we have the inertial force which opposes the direction of motion, so the inertial force, as you know, is given by m into a. Fy is m into a, where m is w by g, weight of the block divided by acceleration due to gravity. So this is how, this is the expression for the inertial force. Now the direction of motion is like this. At the point of contact, at the contact surface, you have frictional force. F acting in the direction opposite the direction of motion. So frictional force F is given by F and normal reaction N. The relationship between this F and N will be F is equal to mu times N, where mu is 0.25. That's given in the problem. So 0.25 N. So this is the free body diagram of the block now. Now I will apply the dynamic equilibrium equation along the direction of motion. I will treat this as x direction, this as y direction. Now let me apply the dynamic equilibrium equation. Dynamic equilibrium equation. It is applied along the direction of motion of the block, that is along x direction. I will take this as positive, and if the force is acting towards left, it is negative. Now here, if you see the forces acting towards right, 750 cos 30 is acting towards right, it is positive. Then you have this frictional force acting in the opposite direction, which is mu times n, which is 0.25 times n. Then this inertial force, which is w by g into a, which is also negative, so minus w by g into a. This should be equal to 0. So this is the dynamic equilibrium equation. Now here W is 1000 Newton, of course, weight of the block. So if I substitute, so if you simplify this, so 750 cos 30, let me simplify that. 750 into cos 30 is 649.5. 649.5 minus 0.25 times n. N is not known here. My W is 1000 Newton divided by D is 9.81 times A. A is unknown here, is equal to 0. Now the equation now I can write here this one as 649.5 minus 0.25 N minus 1000 divided by 9.81 will be 101.9. 101.9 A is equal to 0. So this is the equation. We can call this equation as 1. Now there are two unknowns, A and N. We cannot solve this. Now let me write the equation in y direction. That means perpendicular to the direction of motion. So I can write it as sigma Fy is equal to 0. This is nothing but sigma Fx is equal to 0. So this is along the direction of motion. So dynamic equilibrium equation is written along the direction of motion, that is in the x direction. The other direction is y direction. So when you are writing this sigma Fy0 upward positive, downward negative, I will take this is sign convention. If you see the diagram, this 1000 Newton is acting downwards, it is minus 750 sin 30 is also acting downwards, that is also minus, whereas N is normal reaction is acting upwards, that is positive. So N minus 750 sin 30 minus 1000 is equal to 0. This is the equilibrium equation in y direction. Now if you simplify this, you will get that N minus this becomes sin 30 is half. So half into 750 is 375 minus 1000 is equal to 0, or N is equal to 1375 meters. So this is the value of normal reaction. Once you get the value of normal reaction, we can find out the acceleration of the block A by substituting in the equation 1. So substituting for N in equation 1, so we can get the value of A. So I can write 101.9 times A is equal to 649.5 minus 0.25 times N. N is 1375. Now you will get the value as 649.5 minus 0.25 into 1375, which is 305.75. 305.75. Therefore, A will be equal to 305.75 divided by 101.9. Divided by 101.9, which is 3.0 meter per second square. So acceleration will be in meter per second square. That is, this is the answer. So for this system, when a force of 750 Newton is applied at an angle of 30 degrees on the block, this block starts moving with an acceleration of 3 meters per second square. So this is how we can solve the problem using D'Alembert's principle. Now we will take one more problem, second problem. So in the second problem, of course, it is a problem with yes, two blocks are hung over a pulley like this. See, this is a pulley, which I can call it as smooth pulley. Smooth or frictionless is also called as frictionless pulley. So two blocks are connected to this pulley. One block weighs 300 Newton, another block weighs 450 Newton. So this is a smaller block, 300 Newton is the weight. This is 450 Newton is the weight. So this is the system. So when you consider the pulley as a smooth pulley, the friction will not be there. There is no friction. That means whatever tension force it is exerting this side, same tension force it will be exerting this side also. So T is the tension, both sides. If you consider friction also into account in the pulley, then these two T's will not be equal. So tension here and tension here in the spring will be different. These are the springs. So in this case, the tension carried by both the springs remain the same. The question here is, in this system, find out the acceleration of the system as well as the tension in the spring. So find, the question works like this: find the acceleration of the system. System means both the blocks together is called a system, and the tension in the spring. So since as I already told, frictionless pulley, tension will be there, will be same on both the sides of the pulley. So A we have to find out, T we have to find out. A and T. Now the first question here is, in what direction this system starts moving? Since you have a heavier weight on this side, 450 Newton is greater than 300 Newton, definitely the direction of motion will be like this. So this block will try to come down, whereas this block will go up. So this is the direction of motion. So once you fix the direction of motion, you know that inertia force acts in the opposite direction of motion. Consider the free body diagram of both the blocks separately. Write down the dynamic equilibrium equation for both the blocks. Then you will be having two equations. You can solve, if you solve those two equations, you will get the values of the tension in the spring as well as the acceleration. Now what I have to do is, I will write the free body diagram of 300 Newton block. Simple problem, you have to understand the concept here. So 300 Newton block, weight acts downwards. Direction of motion is like this, I have shown there. Because the heavier block comes down, this should go up. So this is the direction of motion. Your inertia force acts in the opposite direction, M5, which is M into A. M is weight divided by G, weight is 300 Newton. Divided by G is 9.81 times E. A is unknown here. And T also will be there here. Tension in the spring also will be there. So please note that tension always acts away from the block. So I have to show arrow away from the block. So this is the free body diagram for the 300 Newton block. Now if you write the dynamic equilibrium equation along the direction of motion, for treating this upward as positive, this is always you take along the direction of motion force as positive, in the opposite direction you take it as negative. So plus is the forces acting upwards is now plus, downwards is minus. If you use this concept, the equation now becomes this is acting downwards, therefore it is minus, whereas T is plus, the 300 is minus. So what I can write here is T minus 300 minus 300 by 9.81 times A is equal to 0. So this is the first equation you are going to get, or I can write this as T minus 300 divided by 9.81. The value will be 300 divided by 9.81. So the value is 30.58. 30.58 times A is equal to 300. I will bring this 300 to RHS. So this is the first equation we are going to get. You cannot solve this equation because there are two unknowns. Now to get the second equation, I have to write the dynamic equilibrium equation for the 450 Newton block. So for that, if I write similarly the dynamic equilibrium equation, so I have to write the free body diagram of 450 Newton block. FBD of 450 Newton block. So here 450 Newton acts vertically downwards because it is weight. Tension force T in the string will be acting like this, and since direction of motion is downwards here for this block, So your inertia force acts in the opposite direction, that is upwards. Fy will be here. M into A means here M is W by G into A. So W is 450 here. Please note that. So 450 divided by 9.81 times A. So this is the free body diagram for the 450 Newton block. Now let us write the dynamic equilibrium equation in the direction of motion of the block. So whatever forces are acting along the direction of motion of the block, I will take it as positive, and the forces in the opposite direction I will take it as negative. That means in this case direction of motion is downward. So downward forces I will take plus, upward forces I will take minus. Now if you write the equation, so this is an upward force, this is an upward force, this is a downward force. So 450 is positive minus 450 divided by 9.81 times A is negative, minus T is equal to 0. Now here, if you try to simplify this, T you can bring to that side plus 450 divided by 9.81. So the value becomes 45.87. 45.87 A. This should be equal to 450. So this is the second equation we get. Now if you solve equation 1 and 2, there are two unknowns, two equations you can easily solve. So what I will do here is subtracting equation 1 from equation 2. So T will get cancelled. You can see simple equations, simultaneous equations. Subtracting equation 1 from equation 2. So I have to subtract the LHS quantities. T plus 45.87A, T plus 45.87A minus of that. So that is minus of T minus 30.58A is equal to 450 minus 300. So LHS minus LHS, RHS minus RHS. This T you can get cancelled. So the remaining thing what we are going to get is 45.87 plus minus into minus becomes plus 30.58 will be equal to 76.45 times A will be equal to 150. 450 minus 7 is 150. Therefore acceleration is equal to 150 divided by 76.45, which comes out to be 1.962 meters per second square. So that is the unit of acceleration. So this is the acceleration with which the system moves. That means both the blocks move with this acceleration 1.962. So once you get the value of A, you can find out the value of T by substituting for in one of the equations, either 1 or 2. So substituting for A, acceleration term in equation 1, we can get the value of T now. So T is equal to 300 plus 30.58 times A, which is 300 plus 30.58 into A is 1.962. Substitute for A. So the answer what we will get is 30.58 plus 300. 360. So 360 Newton. So tension in the string, which is same on either side of the pulley, is equal to 360 Newton. So this is how we can solve problems by using D'Alembert's principle. We have write out the free body diagram of the object or the block, whatever is there. Then you have to apply the dynamic equilibrium equation along the direction of motion of the block. Always better to take direction of the motion as positive axis and forces acting in the direction as positive, and in the upward direction it as negative. And you can write the another equilibrium equation that is normal to that direction of motion axis, and you can solve for the unknowns.